designing embedded system using Microblaze soft core processor. So Microblaze is actually released by Xilinx. So we will be yes, using that Microblaze core to build very basic applications for our projects. So without wasting any time, so let's make a very basic Microblaze application that will display hello world on your screen. So first you will click project, select new. Right, give this project a name. Click on RTL project. It is the default setting. You don't need to do anything else. So click next. We don't need HDL source files at the moment, so we will leave it as it is. Click next. Constraints file we will be using, but that is for the later session. So today we'll not be needing any constraint file, so you can leave it for now. Yeah, now this is the main important part. So the board that I will be using is Nexys4 DDR. I will select this Nexys4 DDR board, which is provided by Digilent, and it has this XC Arctic 7 100T device, the total pin count of 324 pins. You can further explore its additional information like LUT elements, like number of registers and block ramps. Similarly, you can look at this DSP resource usage guide. So click next. So this is a project summary. Click finish. Okay, now we are ready to make our very first design. So what you will do, you will click this icon, create block design. You can specify any name that you like. Click OK. Okay, so our block design will be made in this window. So what we will do, you will do basically click this board option icon, and first we will connect clocking wizard for our system. So you will click the system clock and drag this element to this window. Right, and it will create a clocking wizard. So you can see that system clock, which is 100 megahertz clock on the Nexys4 DDR, uh, is connected. Uh, After that, you will click on this plus symbol and you add an IP, which is in our case the Microblaze. Okay, you will select this first option, Microblaze. Click on it and it will create this block. Okay, after that, click this option, run block automation. So in block automation, you have different options like how much local memory you want. We will select the maximum 128 kilobytes, and then you want local memory CC, basic or full, and then you have this cache configuration, like how much cache you want in your system. If there is no cache, then just select none. And do you want a debug module or not? And similarly, for connecting the GPIOs switches and LEDs or push buttons, you need an AXI process bars or switch, you can say. So peripheral AXI port should be enabled. So we enable, and then Don't do much changes apart from just changing the size of this local memory and click OK. Okay, as you can see, it has created some additional block components for us, like processor system reset block. Then we have this microblaze local memory, and then debug module. Okay, now we have to connect this reset. So what we will do, we will click, uh, come back again to this design and click board. And here, if you scroll down a little bit, you will see this reset option. So you drag it, so it will actually show you a message that auto connect board component to this green highlighted reset pin. So once you drag this, it will automatically create this uh, connection for you. Click OK. And if you notice a reset, it has created a button or is an input that is provided in our. Okay, after that, run connection automation. Yeah, check it. Or even you can remove this reset button because you will be using the push button actually. So click run connection automation and then select all of these, click OK. And I want to basically show you a bit of some changes, right? Uh, Once we select this connection automation, it has automatically put the reset here. So both are kind of the same things for us. Don't matter that much. Okay, after that, our basic design is done. So you will simply click this regenerate layout and then click this validate design. And if there are no connection issues, okay, right. So it is saying that port polarity does not match between clock wizard. Okay. Most of the processors actually use active low reset. So what you can do is simply go to this locking wizard and in output lock option, you have to basically check this reset type from active high to active low. Some FPGAs have actually an active low reset. So you will select this. Click OK. And then you will again uh, click run connection automation. Click OK. Now you can see the reset is actually active low signal. Or we validate our design again. Now validation is successful and there are no errors. We can now proceed with our project. Okay, so in the sources, you will come back and on design one, right click and create an HDL wrapper for our block diagram. Okay, there is one thing that I forget to attach. I'll come back to that. We simply click this board again and we have to basically connect this USB UART. I'll drag this. Click OK and then run connection automation. OK. After that, we'll again simply regenerate our layout. Right, there's a design again. Okay. Now you can recreate this HDL wrapper. So if we notice the source code, uh, it has created this our system clock, our reset, and then obviously our UART read and write code for us. And a basic design of this our microblaze, you can say it has created an instantiation instance for us. After that, you will simply generate this bit stream, and this process will take some time. So I will simply skip these parts and move on straight on to the application design process. So if you click on the design runs, it will show you the progress, what is currently going on in the background. Okay, once our bit stream is completed, you'll just cancel and click on the file. And first we will export our hardware and do check this include bit stream option. Click OK. Now we are ready to launch our SDK. All right, so this is the main screen that you will see on the SDK after. As you can see, it has AXI UART Lite, and then it has this Microblaze local memory. We don't have much any peripherals right now, but and these are the IP blocks present in the design that we just made in the block diagram. Okay, first we click this new and build a very basic simple application of Hello World. I will call this as Hello World. First platform is our standalone. We are not using any free RTOS or Linux. Click next, and I'll just select this Hello World application. Click finish. Okay, once you have this section of various C ports that has like include header files and your source code files. So this simple C code will just initialize your our platform and just print this hello world screen via the UART terminal. So once this is done, click this option of program FPGA, and it will be loaded. Okay, once your FPGA is programmed, click this run option and then select this launch on hardware system debugger and make sure that you have a serial terminal application like Terraterm, or you can also use the inbuilt this SDK terminal for your application. But we right now I will be using Terraterm. So select the serial port, which in our case is use the serial port on COM5. Click OK. And select this first option, launch on hardware system debugger, and click OK. So it has shown a very basic hello world on our screen. Uh, so let's modify our code a little bit. If you want to use a continuous process, you can simply specify this while one loop. And it will display these hello world lines continuously. So in this manner, you will display a very basic, simple hello world application using the Microblaze code. In the next lesson, I will show you how to create and connect the GPIOs, which includes LEDs and switches. So stay tuned for our next session. Thank you for watching and goodbye.